Okay. So when we talk about ECMO components and circuits, we have about hardware and disposables. Okay. So the different hardwares which we require is the ECMO console, okay, the blender, the heater unit, the ACT machines, monitoring devices, different monitoring devices, and autoclamp. While the disposables, all of you know, pump, oxygenator, tubings, connections, all different connectors, heat exchanger, battle bladder, and cannula. Okay. So this is, okay, I am going to show this all to you. So you have a ECMO console of different types. This is the Medtronic one. Okay, this is an old model. Okay, then you have the Sorin. You have a Meke. This is the Meadows one, and you have Meke machines. So there are different consoles available in India, and there's the Centromeg one. Okay. Now all this has got their advantages and disadvantages. Okay. These are the different consoles which we are available. Now, what is the common thing in console is all console, whichever console you are using, the common thing is you have one knob. This is a knob with which either it's a digital or rotatory knob with which you can adjust the RPM. So what you need to just adjust is RPM, revolution per minute. That's it what you have to adjust. And when you adjust RPM, there will be a flow. So depending on with what speed the your console is moving, it will move your external drive with that speed, and with that the flow will you can adjust the flow with the help of RPM. But remember, we are using a centrifugal machine, so your flow does not only depend on RPM, but it also depends on the preload as well as afterload. So that thing you have to keep in mind. So this is the knob to adjust the RPM, and then you get the flow. Now this console is attached with an external motor drive. Okay. So this is connected to the external motor drive. So whatever the signal comes, it comes with that here, and then you can see the motor drive is moving. Okay. इस पे focus कर. Okay. So when you see the pump will start moving, and this motor drive will move the pump because it is basically based on the magnetic views. So there will be a magnet in the pump which you are using. There will be a magnet in the external motor drive. So that motor drive will move the magnet with that speed, and with that speed the flow will be there. So that is the only thing which you need to do it in an ECMO machine. Okay. Then you have a display board. In the display board, again, there are different types of, yes. I am coming to that. Yeah. Okay. So now, when you see, there will be a flow here. You can see the RPM here. So there's a display unit. Now there are different display units. Some display unit only give what is mandatory is give RPM and give flow. That is a mandatory. Then some display unit has got a P1, P2 monitoring. They have a temperature monitoring. So these are additional feature. What is important must is the RPM and flow. Okay. So now you can see this machine. You can see the external motor drive. This is for Medtronic. Okay. Now coming to Sorin. This is for Sorin. Okay. On kar. On करते उसको. Okay, I'll just switch it on. This is Meke. This is Rotaflow 1. Now there is a Rotaflow 2 which has come up, the new one. This is the old one, Meke. Again, this is the knob to adjust the RPM. Okay, so this is RPM, and you can see the flow here. Okay, so this is RPM and flow. Okay, the external motor drive of this is the external motor drive. Okay. So this is the external motor drive of Meke This is the external motor drive of Medtronic. Similarly, you have a Sorin. This is the external motor drive of Sorin machine. This is Centrimeg, okay, and this is the external motor drive of Centrimeg, okay. And last one is Meadows. Okay. This is Meadows, okay, and this is the external motor drive of Meadows. So what is, you have only one knob to adjust, okay. Now what is important, what you observe, see the external motor drive of Meadows, external motor drive of Mackay, of Medtronic, Sorin, each has different design. Each has got different design. So the pump of them is going to be different. So you cannot mismatch the pump. Okay, you can't use Medtronic pump for Mackay. You can't use the Meadows pump for Medtronic. You can't change the pump because the design is type specific. So you have to use Medtronic pump for Medtronic. You have to use Mackay pump for Mackay. So design is type specific. So you have to be mindful about that. Okay. Other factors, as I told you, which is important is here you can get P1, P2 monitor pressures here. You can get P1, P2 pressures in this also. You can see the pressures in this. In Centrimeg, you don't have a pressures to be, you can't measure the pressures here. And here, if you see Meadows, you get to see all three pressures, P1, P2, P3, all three pressures you will be able to see. Okay. So again, that is the display board, which is different in all the machines. Okay. Now, again, if you see the size of this external motor drive and the size of the pump, it varies. Okay, in all these machines. And as the pump becomes smaller in size, the RPM requirement will be more. Again, I'll be discussing this when I discuss the centrifugal pump per se. But your RPM and flow ratio will be different for different machine. There's no standardized RPM and flow ratio. For an example, if I'm keeping the RPM of 2000, I might get the flow of around 4 liters in case of Medtronic pump. But when it comes to Meadows pump, with 2000 RPM, I will get flow only less than 500 ml. So that depends on the size of the pump. So again, I'm going to come when I come. I'll show you the different pumps. I'll come to that point. Okay. Fine. Other point is you can set the alarm limits for each of them. Machine has got alarm limits, and each machine has got battery backup. Okay. So there's a battery backup in each machine, which might be for half an hour to 1.5 hours. Some machine has got 4 hours battery backup. But again, remember this battery backup. You know it is important because of your transport, definitely. But why battery backup is, you have to remember that battery backup, whatever they claim, is at the time when the battery is new. As the battery gets old up, don't assume that it will still give you support for 2.5 hours or 2 hours or no. It will give you less support. Okay. So always remember, if it's a new battery, yes, it can be 1.5 hours, what they say. But if it is an old battery, the life of the battery will be decreased. Second point, which is important while you are keeping this, depends on the RPM. If your RPM is less, your battery life might be more. If your RPM is more, your battery life will be less. So keep these things in your mind whenever you are, because this is all important when we discuss about transport. This is what all important is. Okay, fine. Then for an ICU in ventilator, if your ventilator stops, you have AMBU. Okay. So there's something AMBU for the ECMO also, and that is what is called as hand crank. Okay, this is hand crank. Okay. So this is hand crank. So when the machine stops because of electric failure, battery failure, you can manually run this. This is what is called as a hand crank. So what you need to do is, you have to take the pump from here, you have to put the pump on this hand crank, and you have to start rotating manually. And there's a direction given. And if you see here, there are values here. 1000, 2000, 3000. So these are the RPM. So you should know what the person was with the RPM. You should know a person was in to RPM of 2000. So you have to rotate this hand crank with the help of that 2000 RPM. Okay. So this is hand crank. Okay. So you have a hand crank. Again, hand crank will be different for different machine. You can't use Medtronic hand crank for a Make A. Why? Because the pump will not fit on this. Okay. So you have this is a Medtronic hand crank. This is the Sorin hand crank, and this is the Make A hand crank. So you have a hand crank for Medtronic, Sorin, and for the Make A machine. You don't have hand crank for centrifugal machine, Centrimeg machine, and Meadows. Okay. What they do in Meadows and Centrimeg, they have a battery backup. They give you two external motor drive. Okay. So this is one external motor drive. This is the second external motor drive. So suppose this stops. Okay. You can take the battery out from here. There are two batteries which they usually provide. Okay. There are the two batteries which they provide. इसको निकाल दे. So if the machine stops, you have to take this battery out, and you have to connect this motor drive to the battery, which is an additional motor drive. Okay. And if you see here, you can adjust the RPM here. So whatever the RPM was there, you can just set the same RPM. The motor will move with that RPM. Okay. So that is what. So you don't have to do manually. It gets with the battery, and this battery usually lasts for around 45 minutes to 1 hour, and then you have another battery which again lasts for 45 hours to 1 hour. So that is a backup. The advantage of this is you don't have to do manually, number one. Number two, if you want to shift the patient, you can shift the patient with just taking these two things out, and you can shift the patient. But only problem is that when you are doing this, you can see only RPM, not the flow. You will not able to monitor the flow in this hand crank. This. Okay. Similarly, in Centrimeg, they provide you two console and two external motor drive. So each Centrimeg machine, when you buy one, it is one. When you buy one, they have two consoles and they will provide you two external motor drives. Okay. So suppose one stops, you can use it. You can immediately switch over to second. Now these two, if they are there, will you think that can we use both the machines for two patients? Ideally, no. The reason is that suppose one stops, you don't have backup, you don't have a hand crank, so you can't do anything, isn't it? Yes, during COVID time, I admit we have used it for two patients, but then we had multiple machines, so we know if there's something goes wrong with one person, we can have we have some other options available. But ideally speaking, it should not be used. Okay, fine. So that is about the hand crank and backup. Okay. So these are the features of different consoles. They have got their own advantage and not disadvantage. How much flow, how much RPM they have, how much flow they can support. Most of the machines can support you for almost 8 to 10 liters of flow. Okay. And the RPM is different. Okay. Again, if you see, the maximum RPM you can do is, in case of Medtronic, is 4,500. Okay. Why? Because with that 4,500, you will be able to achieve the 10 liters of flow. Okay. But if you see Sorin, again 4,000 RPM is the maximum, because Sorin again with the 4,000 RPM you can see you can achieve the flow of around 8 to 10 liters. If you see Make-A, the RPM is 5,000, because probably with the 5,000 RPM you might able to reach 8 liters of flow. Okay. So, and Centrimeg, you can go maximum RPM around 5,500 is the maximum RPM you can go. Okay. While in case of Meadows, you can go maximum RPM around 10,000, because with 10,000 RPM it might able to just give you a flow of around 8 liters. So that's the reason, because the design is different. Okay. Now I'll come to that once I come to the pump. Okay. So these are different machines. I talked about hand crank. Okay. Another part is your heater cooler unit. This is your heater cooler unit. This is heater unit. You can see. Okay. इसको बाहर निकाल देना. बाहर निकालना. Okay. Now heater unit is basically once the blood comes out, it gets cooled. So you want to basically warm the blood. So most of the time it is just a heater unit which you required. Okay. पीछे से निकाल लेना. Yes. नीचे रख दे. रख दे नीचे. So you can see heater unit. There will be water in this. That water will get warmed up and it is going to circulate in the oxygenator. I'll show you where to connect in the oxygenator. You can see the two temperatures here. One is the set temperature, how much temperature you are setting, and one is the measured temperature. So how much temperature is there in the when it comes back from the patient. Okay. So ideally speaking, both the temperatures should be same. Okay. In case your heat exchanger is malfunctioning, you might see a difference in temperature, or if the patient has got fever, because when the patient is on ECMO, fever may not be a proper sign, and you may not get fever because you are cooling the patient or warming the patient. So if patient has temperature more than 36, okay, the temperature will go up. The monitored temperature will go up. That suggests patient is having a fever. Okay. So this is to warm the blood. Okay, heat exchange unit. Usually, what in ECMO you require only heater unit. You don't require cooler. Okay. Like in case of bypass, you require heating and cooling both. Only places where you require cooler is when you are doing ECPR. Okay, for a therapeutic hypothermia. And if the patient is persistently hypoxic and you need to treat it, and there are no other ways, you induce some hypothermia to improve the saturation. Okay. So these are the two places where you require to use cooler unit. Otherwise, you just require heater units. Most of the machines, this is the Mackay heater unit. The temperature range is from 35 to 40. That's the temperature range. In this, you can set. There's another one which is known as Meadows or Delta Stream technology, where you can adjust the temperature from 15 degree to 40 degrees. So here you can do even some cooling also. But in case of Mackay, you cannot do cooling, you can just warm the blood. Okay. There is a heating coil inside. There is a heating coil inside. No, blood is not coming. I'll show you when. I'll come to the oxygen, I'll show you how it moves. Okay. Then is a blender. Yeah. This is blender. Okay. If you see, this is like what blender you have in a ventilator. Okay. This is to mix the air and the oxygen. Okay. So here you have two parts. One is FiO2. This is to adjust the FiO2. So when you set FiO2 100%, it means only oxygen is going. Okay. And you are giving 100% oxygen. Okay. When you keep FiO2 21, it means you are giving only air. So you can blend how much air to be given and how much oxygen to be given, and you can adjust FiO2 with the help of this. This part is known as sweep gauge. Okay. You can see this as a liter per minute. If you can see here, 2 to 10 liters per minute. So that is the amount of gas which is passing through the oxygenator every minute. So you can set 2 liters, 4 liters, so that is a sweep gas. Okay. So this is like your minute ventilation. So that will take care of your CO2. Okay. So always this is sweep gas, this is FiO2, and here you can see one more knob. Now this is in ml per minute. So in pediatric case, suppose your flow is 1 liter, you might keep sweep gas only 500. So this is in ml per minute. So 200 ml to 1 liter, and if it is more than 1 liter, you can use this knob for a sweep gas. Okay. So this is for slip gas, this is for FiO2. That is what the blender is. Sorry. ये ले ले पीछे बाबा, हटा दे. Okay, fine. उसको साइड पे रख. Then you have different monitoring device which are available. This is monitoring device for what you can see in picture is biotrend machine. Here you can monitor circuit saturation and hematocrits. Okay, so you can monitor circuit saturation and hematocrit with the help of these biotrend machines. There are machines which are available where you can see the complete blood gas also online, but that's still not available in India. So what you have a biotrend which can be there. So you can monitor the venous saturation and return line saturation on the circuit and hematocrit levels. Okay. There's also another machine known as ELSA. Okay, extracorporeal life support assessment. Now this machine can give you calculate recirculation. How much is the recirculation exactly? It can calculate it. It can calculate the flow. How much is the flow? And it will calculate whether your oxygenator is getting clogged. Okay, the oxygenator volume also it can calculate. So it tells you to assess not only recirculation but also the clots in the oxygenator, so whether the oxygenator is clogged or not. Again, this is not easily available in India. You have to import it from outside, but not been regularly practiced. Okay, and it's based on basically on ultrasonic indication dilutional techniques. Okay. Then you have bubble detectors. Most of the bubble detectors are there incorporated with the flow sensors. So they when they sense the flow, they even sense the bubbles also. So that is the bubble detectors with the flow sensors. Okay. Medtronic, you have a separate bubble detectors. So here you can. We used to use this previously, but the problem with this bubble detector is even there are some micro air or even there is some movement of the tubes. It is basically based on ultrasonic, so it might wrongly sense as the bubbles and then machine suddenly stops. So usually we have to keep the machines on a interventional mode, not on interventional mode, on alarm mode. So when they detect bubbles, they'll just give you alarm. Machine has, like Mido's machine has got an option that you can put it on interventional mode also. Cardio 2 has got an option that you can put it in interventional mode. So if you keep it on interventional mode, the machine stops suddenly once they detect the air. But then that is the problem, because every time there might be a small air also, or there might be even just movement of the tubes might consider as air, and then it stops, and then it will be a more problem. So usually we don't use these functions to, only we keep it for a as alarm mode. And this was an auto clamp, again not been seen now, which was with Medtronic machine. When we used to have a alarm bubble detector, this auto clamp was put behind the bubble detector. So the moment bubble detector detects the bubble, this used to clamp the tube so that there's no air goes to the patient.